Hello everybody, hope you're doing well. This is Mahmoud Yasari from channel Special K, and today I'm so excited to start a new topic which is about the decimals. So first of all, let's talk a little bit about it. What are decimals? So the thing is that every number that we have seen so far was either a whole number, integer, or something between negative and positive. And we tried our best to avoid anything after the whole number. It means that rather than just talking about 1, 2, 3, 4, or whatever the number is, that we actually do have numbers between 0 and 1 is going to be beside the number that we had, which we know it as a whole number. So right now in this work, we are going to see that how somehow we can get rid of from all of those confusions that we do have about the decimal and make it as a confidence itself. So let's just start with the fact that why decimals, why we are trying to learn them, because believe it or not, everything around us are not only going to be a perfect number. We can say as about the shopping itself, it could be as about just kind of the measuring, about the bank interest and everything. It could be a number that has some values between 0 and 1 itself. So just give you some quick examples about that one. We can start it with money. Obviously, you have some kind of money in your bank account, and that money in the bank account not all the time is going to be a perfect dollar. For instance, I do have 1,275 in my bank account, but I have 83 cents beside of that. So instead of just using those numbers divided once one by one, we can combine them together. So also about the sport, for example, when we are talking about the timing, obviously not all the time we talk about 1 second, 2 seconds, 2 seconds and 75 milliseconds, something like this. And also about the cooking, the science, and you just name it. So it means that decimals are actually a great part of our life, especially about the course, which is about the math itself. So without further ado, let's just get started. That actually, when we are trying to learn something, it would be better to learn it perfectly. So if you remember from the whole numbers, that when we were talking about it, each of those digits that were beside each other's, they had some meanings. For instance, at this point, when I'm talking about 325, based on the place of those values, 5 is considered as unit, 2 10, and 3 as 100. Each of them has value in itself. We also do have the same scenario over here for decimals. So look at this number. I do have 5 decimal number, or point, we call it sometimes as point, 4, 7, 2, and 9. Based on the value based on the place actually they are there, they do have some kind of specific value. So 5 is just considered as our unit. Whatever number that you have on the left side of your point is just considered as a whole number. Whatever number that you have on the right side is going to be considered as decimal number. So the 4 is going to be considered as tenth. Just look at how we pronounce it and how we write it down. The tenth, 7 is hundredth, 2 is the thousandth, and 9 is 10,000ths. It means that when you move from from the first position, which is the 4, to the left, to the right, your value or amount of some kind of the value of your number is decreasing, decreasing, and decreasing. It means that you're comparing point 1 with 0.01, 0.001. So obviously the last one is smaller than the second one, and the second one is smaller than the first one. So this is how we give some values to the decimal as number and based on their places. And obviously if you want to read that, we do have a very, very simple way. So we do have 5.4729, or at some points they would say that 5 and 4,729 10,000. So it would be a little bit challenging to some kind of use the second way. So obviously, to be honest with you, I prefer 2 digits by 2 digits. It means that 5.4729. Okay, that is a very, very good way to do that. So let's just have a quick check about did we understand it completely about these places or not. For instance, look at this example. So I do have a number 3.547, and I'm asking you which of these digits is in the hundredth place. Remember, when you start from the very beginning of the first number that is beside or on the right side of the decimals, we start counting. So the first number is tenth, the next number is hundredth, and 7 is thousandth. And if you want to compare the decimal points to the normal whole number, remember, there is no units there. Units is going to be considered as somehow the common number between the decimal and the whole number itself, so we only have one of them. So as you obviously for the answer of this question would be number 4. So let's move to another part. So far we learned about the decimals, so obviously we are not going to keep them as the way it is. You're not going to keep them isolated, right? So we are also going to do 4 arithmetic operation as we just learned from previous videos on this one as well. Addition, subtraction, division and multiplication. Addition and subtraction are not that kind of hard, but still they have their own way and method. But division and multiplication, they could be a little bit challenging. We will work on that. So let's first of all start with addition. As we all know, for adding 2 numbers, doesn't matter if they are decimals or whole, we have to put the numbers beneath each other, one on the top, one beneath another one, or at this point, for example, if you do have 4 or 5 numbers, one beneath another one. And we have to make sure when you write them down, you put all of those digits based on the place values under another one which has the same value as the last one. For instance, when we are talking about 325 and 57, and I ask you to add these 2 numbers, you have to make sure that 325 means 5 is a unit, 2 is 10, 3 is 100, 7 should be in the same place or the same value as 5. So I do have it at 7 and 5 the same. So it means that these 2 numbers beneath each other, one is beneath another one, and 5 is also beneath the number 2. The same scenario is happening over here, but with one difference. The fact that the number of digits that you see on decimals are not going to be the same, and sometimes we have to use some extra help. What does that mean? Let me give you an example. Imagine that you do have a number 3.5. I will give you another number as 3.50, and after that I will give you another number as 3.500. The way that you can see over here is that I use some extra zeros. In the meantime, I didn't change any value in the number itself. Maybe some of you that say that, okay, how is that happening? So this is a rule, this is an agreement about that. Whatever number that you have on your decimals, if you put 0 after the last number, for instance, at this point it was 5, right? If you put any 0 after the last number, it doesn't count. The only thing that we use that 0 for is for getting some 8, for adding, subtracting, division, and multiplication. 3.50, 3.500, 5,000, 5 million, doesn't matter. As long as that number or that 0 would be exactly after the last digit of decimals. So at this point, obviously, I have to write down these numbers based on their place value, right? I do have 0.865. By the way, there's sometimes that instead of just 0.865, they would write it down as 0.865. So it means that actually it's 0.865. So I do have this number, 0.865 plus 1.3. So right now you see a problem over here. Why? Because imagine that I only have these 2 numbers. Because at this point, I do have 0.865 and I do have 1.3. I only have 2 digits for the second one, and I do have 3 digits for the first one. How should I write them down? First of all, remember about the whole numbers. The whole number for the first one is 0. The whole number for the second one is 1. Period. Okay? No problem. But here's the thing. I do have 865, and 8 is 10th. 6 is hundredth, and 5 is thousandth. How should I write the second number beneath that? Look at number 3. So obviously 3 is 10th, right? So obviously 3 should be beneath the 8 itself. But what about other numbers? If you remember that from the last part, I told you, it doesn't matter how many zeros you would add after the last decimal number that you have. So it doesn't matter how many zeros that I put after 3. Still doesn't count. 1.30, 1.300 or 3000. Doesn't matter. Still 1.3. So in order to help myself a little bit more, in order to keep those values, I mean at this point, when I do have 6 and 5 for the first number, I don't have any two values for the second number, right? So I have to find a way in order to somehow keep them on track. That's why I'm going to put zeros. By putting the zeros, somehow I do have the values for 5 and 6 and I can add them. So obviously you can see if I add 0 by 5, it would be just a 5, 0 by 6, just 6, nothing would change, right? So this was for only 2 numbers. At this point, I do have 5 different numbers and I have to take care of all of them. So right now the situation would be a little bit complicated. How should I do that? So I do have the first number, I do have 0.865, and for the second number, I do have 1.3. We just learned that for the first number and second number, in order to be aligned with each other, I have to add only 2 zeros, right? So by 2 zeros, the problem is going to be solved. However, for the next number, you can see that we do have a problem. And what is that problem? That problem is that on decimal point, this number has 3 values. Again, just like the thing that we have, but on the whole number, it has 3 digits as well. So what am I going to do? So at this point, I'm going to keep again the same values beneath each other. So I do have 0 as my unit. I do have 1 as my unit. So I have to keep 5 as units. What would happen to 7 and 3? I have to move them to the left. At this point, I don't have any value for the last 2 numbers, so I'm going to just write down all of those units beneath each other, and after that move then 7 and 3 on the left side. And hopefully for the next number, I can find something that could be matched with this ones, right? So still, I don't have to do anything. Again, I do have 3 digits for the first number. For the first decimals, 3 decimals. For the second one, I added 2 zeros. I have 3 decimals. For the second one, I do have 006, still 3 decimals. But for the next number, I do have a problem. What is that? The problem that we have for the second number actually comes from 2 sides. One side is from the decimal itself, because at this point you see, instead of just having 2 or 3 digits, I have 4 digits. It means that at this point I don't have to add any 0, but I have to be careful where am I putting those numbers. So 1, let's just talk about the decimal. 1 is going to be considered as 10th, right? So 1 would be beneath the 0, beneath 3, which you had the 3, and beneath the number 8. All of the 10th should be in the same column. For the next one, 3 under 0, under another 0, under 6, 5 under 6, under 0, under 5, and at this point, you see that all of those previous 3 numbers only contain 3 digits. Actually, for the second number, we added 2 digits, but it doesn't matter. But only contain 3 digits. It means that at this point, I have to use the fourth hypothetical digits, which is going to be there in order to just help me. It's not going to add any value to my numbers. Again, by putting zeros after the last decimals or after other zeros, you're not adding anything to the value. That number is going to still be the same. So by adding the 0, by adding another digit, the only thing that I'm trying to help myself is that I want to use a way to the 7 not be alone. So that was about these numbers, but what about the last number? Because at this point, the last number is just a whole number, 735. So I believe you don't have any problem with that, with the whole number. But what should happen to the decimal point? Again, when you do have a number like 1, 1.0, 1.00, 1.00, at this point, I don't have any decimal number to put another 0 beside that. So at this point, when you do have only whole number and there is no decimal number, the way that you can do is that you just add one hypothetical 0 there. two hypothetical zeros there, three hypothetical zeros there. Nothing would change. Adding zeros to a whole number on decimal point, remember, only on decimal point, because maybe some of you would say that, okay, I would add 0. The reason that we do have this dot or this point is that we have to divide the number that has a 0 when it has meaning with another one that doesn't have any meaning. For instance, when I do have 10, when I do have 100, those zeros actually mean something. But at this point, these extra zeros, they don't mean anything, so I can do that. So why we're trying to do this, because as you can see for the last 4 numbers, I do have all of those decimals, 4 decimals. So in order to keep them, all of them in a very neat and nice column, I still have to make sure my last number has also has the same number of digits on the decimal point as the previous ones. That's why I have to use 4 hypothetical decimal, 4 hypothetical zeros that are not going to change any or add any value to the number, but they're going to help me for the addition. So I do have everything that I need, and as you can see, it's just like a normal math. We know from the previous videos how we can do that. Add them up. If a number is something more than 9, you have to move it as a carrying number to another one, so on and so forth. So I will totally leave it to you right now, but to be honest, let's just do that together, because at this point we do have a point number. Maybe some of you is getting a little bit confused. So let's do it this way. What do I have? Let me just change it to this point. Okay, I do have 0 plus 7 plus 0 plus 0 plus 0, 7. Keep it that way. I do have 0 plus 5 plus 6 plus 0 plus 5. It would be 5 plus 6, 11 plus 5, it would be 16. Remember, 16 contains 2 parts, 10 and 6. I have to move this guy to the left side, which is going to be considered as a carrying number, and I have to 6 at this point. Let's move to the another part. 0 plus 3 plus nothing plus 6. Remember, I still have another 1. So that would be 10. Everything would move to the left side. I will keep the 0 at this point. 0 would be over here, 1 to the left side. So what do I have? I do have 1 plus 3 plus 8, which is going to be 12. Remember, I had 1 or 1 carrying number from the right side. Everything right now would be 13. So keep the 3, and after that, here's the fun part. So you see that all of those 4 or all of those 5 numbers, they had 4 digital numbers for decimals. We also have to keep 4 digital decimals for our final number. So when you're done with your 4th part, with your decimal part, just keep this dot at this point, because at the end you are going to see that whatever number that you have after point is going to be considered after point. Whatever number that you have on the left side or before that is going to be considered as a whole number. So right now, what do I have? I do have some kind of 1 as a carrying number. Let me put it this way. I do have 1 as a carrying number. So this guy was a souvenir from our previous part. So remember, when your decimal number is increasing, for instance, when I do have at this point, I had a number 13. So this 10, instead of just being kept in the 10th value, is going to be moved to the units. So that's completely makes sense, right? Just like the way that we did for the normal addition without any point. So 1 would be over here. Again, I do have 1, 1, 5, 1, 5. It would be 13 again. Move to the next part. I do have 8 and so on and so forth. So you don't have any problem with that. The only thing that I was trying to focus on was over here, that how you can put this dot there in order to understand completely that what is going on with the decimal itself. So let's move to the next part, subtraction. Subtraction is also so simple. It's just like the way that we had for the addition. At this point, instead of just adding, we are subtracting. So you're already familiar with borrowing method. For the addition, we had carrying method. For this one, we do have borrowing method. For example, at this point, you see that I do have 2 numbers. Again, they have to be written down under one beneath another one and in the column way. Again, I believe you can tell me why I do have this extra 0. Because for the first number, I have 4 decimal digits. For the second number, I have 3 only decimal digits. In order to satisfy all the conditions about the second one and the first one in a way that both of them contains 4 digits, I have to use another extra 0, while the value is not going to be changed at all. So I do have the 0. Again, if I subtract 0 out of 1, it will be just 1 itself. 2 out of 5, 3, 0 out of 2, 2, 1 out of 1, 0, 4 out of 2. Again, I can't do that, so we are using the carrying method. We are going to make this guy as 5 and add 10 to number 2. So it would be 12 subtracted by 4, which is 8. 2 subtracted by 5 is going to be 3. If anything like this happened to your decimal point, you also have to do the same way. Nothing would change.